Welcome to the Spelling Bee Ninja podcast, your hub for free educational content that sparks curiosity and inspires learning. Join our community of passionate learners today. Together, we can explore fascinating subjects and help each other grow. If you're ready to dive into the world of architecture and mathematics, this episode is just for you. In our journey today, we're going to explore the critical role that mathematics plays in architecture. Have you ever walked past a stunning building and thought about how it was designed? The truth is, behind every magnificent structure lies an intricate framework of geometry, measurement, and proportions. From ancient pyramids to modern skyscrapers, mathematics is the backbone that supports our built environment. Our first topic is geometry. Geometry deals with shapes and spatial relationships, and it is one of the most apparent ways that architects use mathematics. In architecture, a floor plan is a two-dimensional representation of a building, while building shapes often involve three-dimensional geometry. Geometric shapes are everywhere. You can see rectangles in the shape of buildings, circles in columns and domes, triangles and roofs, and arches in doorways and bridges. The ancient Egyptians used precise triangular geometry in their pyramids, which allowed for structural integrity and beauty. Next, let's dive into the fascinating world of proportions and the golden ratio. This ratio, which is approximately 1.618 to 1, has influenced design for thousands of years, creating a sense of harmony and balance. You can find this ratio in famous structures such as the Parthenon in Greece, where its facade is designed using the golden ratio for proportion. Many Renaissance buildings also embraced this mathematical principle, ensuring that spaces felt naturally pleasing to the eye. What's truly interesting is how modern architects continue to apply the golden ratio, making contemporary spaces that are both functional and aesthetically beautiful. This leads us to the structural calculations necessary for safe design. Architects and engineers perform numerous calculations to ensure their buildings can support various loads. These include dead loads, which account for the weight of the materials used in the building, and live loads, which consider the movement of people and objects within the space. Additional factors like wind and seismic forces also play crucial roles in these calculations. Mathematics aids in determining the necessary size and strength of structural components, ensuring that everything is safe and sound. It's remarkable how much thought goes into every square foot. Now, let's talk about scale and proportion. Scale refers to the size of a building in relation to humans, while proportion pertains to the relationship between different elements of the design. This is where mathematics steps in again. Architects consider the dimensions of doors and windows to fit the human scale, making spaces feel more inviting and accessible. This thoughtful design element can significantly enhance how people interact with the space they are in. For example, ceilings can create different feelings based on their height. Tall ceilings may give a sense of grandeur, while shorter ones can feel cozy and intimate. Symmetry is another essential aspect of architectural design. Symmetrical designs provide a sense of order and harmony, widely appreciated in formal architecture. For instance, look at the White House in Washington, D.C. Its bilateral symmetry gives it a dignified appearance. In contrast, the Taj Mahal, famous for its extraordinary balance and beauty, also exhibits perfect symmetry, making it a visual treat to behold. Architects use symmetry to highlight key features in their designs, contributing to the building's overall aesthetic appeal. Also, how is math shaping sustainable architecture? The answer lies in the careful calculations architects make to create energy-efficient buildings. Sustainable design aims to minimize environmental impact, and mathematics is at the core of this process. Architects perform thermal load calculations to understand heating and cooling needs, and solar angle calculations to make the best use of natural light. These mathematical insights guide the creation of buildings that are not only efficient but environmentally friendly. In fact, one of the leading sustainable buildings in the world, the Edge in Amsterdam, utilizes advanced mathematical strategies to optimize its energy use. Throughout history, several architects have been renowned for their deep understanding of mathematics. Le Corbusier is famous for using the golden ratio in his designs, while Frank Lloyd Wright drew inspiration from nature's geometric forms. Buckminster Fuller revolutionized architecture with his geodesic domes, and Zaha Hadid introduced complex geometries using computational design. Each of these architects leveraged mathematical principles to create innovative and inspiring structures that continue to amaze us. In recent years, digital technology has transformed the field of architectural mathematics. Computer-aided design, or CAD, has allowed architects to perform complex calculations quickly and accurately. This technology enables them to create 3D models and to visualize how their designs will interact with various forces in real time. Furthermore, advancements like building information modeling and generative design are reshaping the future of architecture, allowing for intricate designs that respond to environmental data. The Gherkin in London, for instance, boasts a shape designed through advanced mathematical calculations to ensure energy efficiency and structural stability. And finally, as we look towards the future, mathematics will play an even more pivotal role in architecture. With the emergence of 3D printed buildings, smart buildings that adjust to their environment, and designs inspired by nature, architects will rely on advanced mathematical knowledge more than ever. They will need to address significant challenges such as climate change and energy sustainability, creating resilient structures that contribute positively to the planet. The possibilities are endless. Imagine a world where buildings not only stand tall but also work harmoniously with their surroundings. And as we conclude our exploration of mathematics and architecture, it's clear that math is more than just numbers and equations. It's a vital language that shapes the spaces we inhabit, allowing architects to craft buildings that are safe, functional, and beautiful. From the ancient wonders to futuristic concepts, math and architecture are indeed inseparable partners in creating our built environment. The next time you gaze at a remarkable structure, remember the intricate math that makes it possible. Today, we unraveled the profound connection between mathematics and architecture. We delved into the significance of geometry, proportions, and the golden ratio, uncovering how these concepts influence architectural design. We examined the importance of structural calculations for safety and stability and discussed how scale and symmetry create inviting spaces. Additionally, we highlighted sustainable design practices and the pioneering work of renowned architects who utilized math to innovate. We also explored the impact of technology on architectural practices and envisioned a future where mathematics continues to guide architects in crafting extraordinary structures that harmonize with our world. Thank you for joining us on this enlightening adventure into the math behind architecture. We hope you enjoyed learning how mathematics shapes the spaces we live and work in. If you loved this episode, make sure to subscribe to the Spelling Bee Ninja podcast for more exciting educational content. Together, we can inspire curiosity and knowledge. Until next time, keep dreaming big and exploring the wonders of the world around you.